Hearty welcome to the video on answers to questions for revision, class 12 mathematics. At this video, 15 questions comprising MCQ, assertion and reasoning, very short answer, long answer, and case study questions are compiled. The topic discussed at this video is integral calculus, both the definite and indefinite. Let's move on to question number 1. E power x into cos x minus sin x dx is equal to. Here we have noticed that some children will be trying to split the integral into 2 and then do it by integration by parts. That is also correct. But be careful. This question is a question of 1 mark. However, we should be very careful and we have to use the one of the results which you have seen. Now we are just taking that integral now. We have seen one result. If it is e power x, be careful. It cannot be e power anything other than x. E power x into a function plus its derivative dx is e power x into that function. For here your job is to identify which is the function and which is its derivative. Because cos and sin, cos and sin derivative, cos derivative sin. Therefore you should be careful with that. For now I am writing this as cos x plus minus sin x because derivative of cos x is minus sin x. It is function plus its derivative. Therefore, I am identifying function as cos x and the derivative as minus sin x. Therefore, the answer is e power x cos x. Therefore, the option A is correct. Let's move on to question number 2. Whenever you are getting a modulus, you have to check whether the nature of that modulus function in the given interval. Sometime it may be positive, sometime it may be negative. Let us check out now. Modulus x minus 2 is x minus 2 for x minus 2 greater than or equal to 0 minus of x minus 2 when x minus 2 is less than 0 because of modulus. What is the meaning of x minus 2 greater than or equal to 0? X greater than less or 2 and x minus 2 less than 0 is x less than 2. Therefore, we have to find the interval now. It is minus 1 to 1. Minus 1 to 1 is less than 2. Therefore, it is totally minus of x minus 2. Modulus x minus 2 is minus of x minus 2. Now you can find it now. Therefore, it is the final answer is minus 2. Therefore, option D is correct. Go to question number 3. The value of sine inverse of cos of pi by 2 minus 3x. Very easy question. We have to make use of the idea what is cos of pi by 2 minus 3x. Cos of pi by 2 minus 3x is sine 3x. Therefore, it is sine inverse of sine 3x. Therefore, 3x. Therefore, it is 3x square by 2. Therefore, option B. Direct question. Question number 4. 2 upon e power x plus e power minus x the whole square. Now, be careful. In these types of problem, you may find out the integration, but we have to check the correct answer which is given there. I am taking the integral and I am writing it as e power x plus 1 by e power x the whole square. I am taking the LCM. E power 2x will go to the numerator. Now you are seeing the integral that differentiation of e power 2x plus 1 or e power 2x is in the numerator. But I can tackle this problem by means of substitution. I am substituting. Now the integral become du by u square, which is nothing but minus 1 by u plus c. But now remember, this answer which you are getting is not in any of the options. Now we have to do some alterations. For that I am multiplying and dividing by e power x. It will become e power minus x and e power x plus e power minus x. Therefore, we are just doing that. Therefore, we will get the answer like this. Or multiply by e power minus x. Both of them the same. Therefore, we are getting the answer as minus e power minus x by e power x plus e power. You are just multiplying by e power minus x. Right. The value of integral 0 to pi by 2 log of 4 plus 3 sin x by 4 plus 3 cos x. We have to make use of the properties. We cannot do this problem by integration by parts. Be careful. Let us try to use the property. Wherever x comes, replace it by pi by 2 minus x. Therefore, we are replacing. It will become 3 cos x. Sin pi by 2 minus x is cos. Cos pi by 2 minus x is sin. We are getting two integrals. Therefore, half into 0 to pi by 2 sum of the integrand. Though both the integrand you simply add. But some book will use the 2 in the left hand side or otherwise you can have half. Both are one at the same. Now, when you use the property of log m plus n, log mn, you will get that log 1. What is log 1? 0. Therefore, option C is correct. So, the answer is 0. Let us go to question number 6, assertion and reasoning. It is given the assertion as 2 to 8, square root of 10 minus x by root x plus root 10 minus x. Dx is equal to 3. Now, one of the properties is given. Now, let us try to use the property given in the reason to solve the assertion. Therefore, 10 is 2 plus 8, 8 plus 2. Therefore, I am using the property now. Therefore, I am replacing x by a plus x minus x. That is 2 plus 8 minus x, 10 minus x. Now, it becomes like this. Therefore, I am getting, I started with root 10 minus x. I am ended with root x by the same denominator. So, now I have to add the numerators. Each integral is equal to half into sum of the integrand. This formula you can remember, or 2a is equal to integral of the sum of the integrand. Both are not the same. Now, when I simplify it, I am getting that integral dx. Therefore, the answer is half into 8 minus 2. Therefore, the answer is 3. Therefore, the assertion is true. We are getting the final answer as 3. Now, let us go to the reason. Reason is a property of definite integral. Now, this is true, but remember, this property is used to prove the assertion. Therefore, reason is the correct explanation. Therefore, both A and R are true, and R is the correct explanation of A. Good. Let us go to the question number 7. Assertion is f dash of x is equal to x plus 1 by 1 plus x square, and f of 0 is equal to 0. Then f of x, we have to find out whether it is correct. And reason is given one integration formula. Let us check out. Assertion is we are finding f dash of x. What is f of x now? Integration. Therefore, we will integrate. Normal integration, x square by 2 plus tan inverse x plus c. To eliminate that c, f of 0 is equal to 0 given. But I am substituting. I am getting c as 0. Therefore, f of x is x square by 2 plus tan inverse x. Therefore, assertion is true. Let us go back to the reason now. Reason is integral tan x dx is equal to log secant x plus c. Formula is correct. But this is not used to prove the assertion. In assertion, this formula is not at all used over there. Therefore, both A and R are true, but R is not the correct explanation of E. Let us go to question number 8. Integral x power 9 by 4x square plus 1 whole power 6 into dx. Now here, we have to be a little bit careful. No substitution works out over here. Now let us try this like this. Let us take x square outside from the denominator. It will become x square whole power 6 into 4 plus 1 upon x square. Now what is that x square whole power 6? It is x power 12. It will get cancelled with x power 9, or you will get 1 upon x cube into 4 plus 1 by x square into power 6. Now we can visualize it like this. We can visualize it as 1 by x cube is nothing but derivative of 1 by x square. Actually, 1 by x square derivative is minus 2 upon x cube, but there is 1 by x cube is there. But I am doing substitution now. I am getting dx by x cube term. I can replace it by minus 1 by 2 du. I am substituting now. I am getting 4 plus u whole power minus 6, which is nothing but 1 by 10. If you do the resubstitution, 4 plus 1 by x square whole power minus 5 plus c. Go to question number 9. Sin x minus x cos x by x into x plus sin x into dx. That is, we have to do some alteration so that we can do this problem by substitution. How to do it now? Add and subtract x in the numerator. Add and subtract x in the numerator. Now you take it out. X plus sin x outside minus x into 1 plus cos x is the second term. When you split it into two terms, first term is 1 upon x. Second term is 1 plus cos x by x plus sin x. Take it out now. First integral is very easy. It is log x. But the second integral, closely watch it. It is a problem of substitution because derivative of x plus sin x is 1 plus cos x. Therefore, we are doing the substitution only for the second integral. Second integral is coming as log x minus log u, which is log x minus log of x plus sin x. This is the final answer. Here is a small adjustment, adding and subtracting x in the numerator. Let us go back to question number 10. Evaluate sine 2x into tan inverse of sine x into dx. Now this problem can be done by integration by parts, but before we go for that, replace sine 2x as 2 sine x cos x. Now this cos x is the derivative of sine x, all of you know. So now let us try to do substitution. I will take t is equal to sine x, dt is equal to cos x dx. This will become 2 integral t into tan inverse t dt. Now this can be done by integration by parts, which is algebraic and inverse trigonometric function. All of you know, in integration by parts, u should be taken as the inverse trigonometric function and dv to be taken as the remaining, that is t into dt. You don't need to take the 2, 2 can be kept outside. Now I'm finding du, I'm finding v. I'm putting in uv minus integral v du. Don't try to put that 2 outside. 2 is always outside now. Now you are getting two integrals. Now that is one is t square into tan inverse t, that is outside the integral, and plus t square upon 1 plus t square. Here you can add and subtract 1, and first integral will be 1, second integral will be 1 by 1 plus t square, which is nothing but t minus tan inverse t. Minus sign goes inside. Now do the resubstitution. What is t? T is sin x. Therefore sin square x into tan inverse sin x minus sin x plus tan inverse sin x plus c. No need to do more simplifications out of it. Let us leave it as. Go on to question number 11. E power x into square root of 1 plus sin 2x by 1 plus cos 2x. Now this is a problem where already we have discussed. E power x multiply any term comes, it will be a function plus its derivative. But it may not be directly available to you. You have to do some adjustment. Let us see what type of thing which we have to do. For sin 2x, I am writing 2 sin x cos x. For 1, I am writing sin square x plus cos square x. Therefore, it will become sin x plus cos x by 2 cos square x. Split it into 2. It will become sin x by cos square, which is secant x tan x. And cos x by cos square is 1 by cos x, which is secant x. Now, can you identify which is the function, which is its derivative? Secant x is the function. Secant x tan x is the derivative. I think this question which you are seeing e power x into secant tan x plus secant x is a question in NCERT textbook. But now they have gone little bit in a reverse one. Therefore, f of x is secant x, derivative is secant x tan x. Therefore, we are writing it as e power x into secant x plus c. Go back to question number 12. Evaluate 0 to pi by 2, 2 log sin x minus log sin 2x. This to be done by properties. Replace x by a minus x. Replace x by pi by 2 minus x. Let us replace. All of you know what is log sin 2x. It is log 2 into sin x cos x. Once again, it is log 2 plus log sin x minus log cos x. Now log sin x, 2 log sin x and minus log sin x will get cancelled. But you will get log sin x minus log 2 minus log cos x. Now you replace x by pi by 2 minus x. Therefore, you can replace either in sin or cos. Don't do in both. Therefore, in cos, I am replacing it by pi by 2 minus x. It will become log of cos x. Log sin x, integral log sin x getting cancelled. You are left out with only minus log 2 integral dx. Therefore, the answer is minus pi by 2 log 2. This is a very, very interesting problem. It is in the NCERT textbook also. Well, question number 13. Evaluate integral 0 to pi by 2 x sin x cos x by sin power 4 plus cos power 4. 0 to pi by 2 problem. Therefore, replace x by pi by 2 minus x. Let us replace. I am replacing everywhere. Sin pi by 2 minus x will become cos. Cos pi by 2 minus x will become sin. In these types of problem, you have to remember, in maximum problem, that is maybe 99%, denominator will not change when you apply it. There are some problem where denominator changes also. I am not telling that won't happen. But in many of the problem which is in your textbook, maximum problem, maybe 90% you can call, denominator will not change. Now you can see denominator is same, sin power 4 plus cos power 4. Now you add the numerators, half into sum of the two integrand. I am always using half into sum of the two integrand because you will not forget the 2 at the end. Some book will start with the 2a. 2a is equal to. Anyway, you choose whichever is convenient to you. Now you add the numerators. When I add the numerators, I am getting only sin x cos x by sin power 4 plus cos power 4. Now how to tackle it now? Divide the numerator and denominator by cos power 4. Therefore, numerator will become tan x into secant square. Denominator becoming 1 plus tan power 4. Now can you visualize it now? Derivative of tan x is in the integral. Therefore, we are going for substitution. Tan square x derivative is inside. It is nothing but 2 tan x into secant square x. Therefore, tan x secant square x is there in the numerator. Therefore, that is half into d. Therefore, we are doing a problem of definite integral substitution. It is always advisable to change the limits. When x is equal to 0, what is u? Tan g square 0, 0. When x is pi by 2, u is tan square pi by 2, which is infinity. Therefore, it will become pi by 4, 0 to infinity, half du by 1 plus u square. What is 1 plus u square formula? Tan inverse u. What is tan inverse infinity? Pi by 2. Tan inverse 0 is 0. Therefore, the answer is pi square by 16. It's a very famous problem. Prove that it is equal to pi square by 16 also. So many times they have asked it in the CBSE question paper. Question number 14. Evaluate root x square plus 1 into log x square plus 1 minus 2 log x by x power 4. Let us try to use the property of log. Also, not only that, let us try to simplify it now. Log function separately and then this algebraic separately. Square root of x square plus 1 by x power 4. Now, how you can write it? And you can write it as square root of x square plus 1 by x into 1 by x cube into 1 by x cube into log of x square plus 1 by 1 plus x square. Now it will become, when you just do it, it will become root 1 by x square 1 plus 1 by x square into log of 1 plus 1 by x square into 1 by x cube into dx. Now you are seeing over here that 1 by x cube dx is nothing but derivative of 1. We'll just take it now. 1 plus 1 by x square we are taking. Now its derivative is minus 2 by x cube. Therefore, 1 by x cube dx can be replaced by minus half into dt. What will happen now? Square root of 1 plus x square. 1 plus 1 upon x square will become root t into log of 1 plus 1 by x square will become log t into minus half into dt. Now this is the integral now. Just to visualize this integral now, it is root t into log t. Log function and algebraic function coming under which type? Integration by parts. Take u as log t. Isolate dv is equal to root t dt. Finding du and v. Substituting uv minus integral v du. Don't forget that minus half. Then I am multiplying it. I am doing the integration. I am doing the resubstitution. Now you can simplify it and you can leave it as it is also. I have taken 1 by 3 into 1 plus 1 by x square whole power 3 by 2 outside and then I have given you the answer. Let us go to the case study question. In the case study question, they have explained what do you mean by antiderivative and what are primitive. And they asked you to find the antiderivative of this function. What is the meaning of antiderivative? It is the integral only. I have to integrate sin cube x by cos cube x by cos cube x. It is sin cube x by cos power 6, which can be written as sin square x into sin x by cos power 6. Sin square can be written as 1 minus cos square into sin x by cos power 6. Now you got an idea now. This integral is containing the derivative of sin x. Sorry, derivative of cos x. Sorry, derivative of cos x, which is sin x dx. Therefore, I am replacing it by t is equal to cos x, dt is equal to minus sin x dx, but I have only sin x dx, therefore it is minus dt. Substitute now, it will become 1 by t power 6 minus 1 upon t power 4 into dt. Minus sign comes outside. We are doing the integration. Replace t by cos x. Now you can write the answer like this also, because 1 by cos power 5 is nothing but secant power 5. Second question for 2 marks once again. They want the primitive. What do you mean by primitive? Primitive is once again antiderivative. We have to find the antiderivative of the function. equate it to a into 1 plus x square whole power 3 by 2 plus b into root 1 plus x square. Now this problem, x cube upon root 1 plus x square, therefore write that x cube as x square into x, and now do the substitution. 1 plus x square as u, it will become u minus 1 into half into du by root u. Now you can split it into 2, u by root u into 1 by root u power 1 by 2 minus u power minus 1 by 2. I have done the integration. This is the final integration now. Half into 2 by 3 into 1 plus x square whole power 3 by 2 minus 2 into root 1 plus x square. I have done the resubstitutions also. This is the final term by multiplying throughout by 1 by 2. Now you simply equate what is A, 1 by 3, what is B, it is minus 1. Okay, well, we will continue our discussion in the next video.